Hello students, it's a Young's double slit experiment, and in this class I am explaining Young's double slit experiment. I call it as YDS in short. I am deriving the path difference using this experiment, and also I am deriving the expression for fringe width. So in the annual exam, some questions have appeared from this portion. First one is what is interference? Write the condition for path difference in case of constructive and destructive interference for 3 marks. You have to mention one statement, one condition for constructive, another condition for destructive. Then you have to define interference. For all these three, you get 1 mark each. This question appeared in March 2015, July 2016. Another one is describe the Young's double slit experiment for 3 marks. You have to describe this experiment with a simple diagram, and it appeared in June 2015. And third one is obtain the expression for fringe width of interference fringes in Young's double slit experiment for 5 marks. Here you have to explain the whole experiment along with the expression for path difference. This question appeared in 2014 and July 2014. Then before going to the actual portion, let us recap what you have learned in the last class. You have to first recall the definition of interference. Interference is nothing but modification in the intensity of light due to superposition of two waves from coherent sources. Whenever path difference between two waves is equals to an integral multiple of lambda. N lambda means integral multiple of wavelength. Where n is integer, it can take value 0, 1, 2, 3. Then you will have a constructive interference, and the intensity will be maximum, and whose value is equals to 4 I naught, where I naught is the intensity of any one wave. Then if the path difference is equals to n plus half lambda, fractional part of lambda, then n can take 0, 1, 2, 3 and so on. In such case, the destructive interference will take place, and resultant intensity will be 0, and these are the two important conditions you should remember. If you define the interference, then you get 1 mark. If you write this condition, path difference equal to n lambda, we get this constructive interference, and the intensity is 4 I naught, then you get 1 mark. If you write the second condition for 0 intensity, path difference equal to n plus half lambda, where n can take 0, 1, 2, 3, and result is destructive interference, then we get 0 intensity. If you write this much, you get 2 marks, 1 mark for definition of interference. So let us start the experiment. Thomas Young is the name of scientist who is a British physicist. He used one simple technique, lock the phases. Lock the phases is a very unique technique, because you cannot produce a coherent sources by taking two independent light sources. Practically it is very difficult, but Thomas Young, he used this technique to produce the coherent sources, a pair of coherent sources from single light source. He made two pinholes S1 and S2 on the one cardboard. They are separated by very small distance. I will show you that diagram first. This is the one light source, I call it as S, and this light is now falling on a cardboard. This cardboard is having a small pinhole S1 and S2 separated by a distance small t. Then the light coming out from S1 and S2, they are moving towards the point P on this screen. This is a screen, and the light source coming out from S1 and S2, they are moving towards the point P. And I draw one horizontal line from S1 which is going to meet at Q on the screen. Similarly, a horizontal line from S2 which meet at R on the same screen. Then one more horizontal line from the center of S1 and S2 which is going to meet at C, which is a center of the screen. Then the distance of S1 from this center of the screen is d by 2, and the distance of S2 from the center of the screen is also equals to d by 2. Then the p is a distance where the light waves from S1 and S2 they are going to intersect, which is situated at a distance x from the center of the screen. And I draw one perpendicular from S1 on S2p, and I call it as point n, because n is the point on which uh, I draw the perpendicular from S1. Then this is a angle, this is a small angle theta, and the distance between this source and screen is capital D, and this S2n is nothing but path difference. This is the difference between these two distances. S1p is a one distance, S2p is a another distance. Two paths through which the light from S1 and S2 traveling, and they are reaching the point P. Look at this diagram. Both path S1p and S2p, they are not equal. S2p is greater than S1p. How much it is greater? It is greater by S2n. So this is a difference between the two path S1p and S2p. Hence this difference is called as path difference. You cannot measure this path difference by just taking a scale and measuring from S2 to n. No, it is not the correct technique. S1 and S2 are the pair of coherent sources. From the pair of coherent sources, light waves they are moving from S1 and S2 towards the point P, and they intersect at point P. When they intersect at point P, they will be either in phase or out of phase. So depending upon this path difference, so at point P you may get maximum intensity or minimum intensity. So this is what I have explained in the previous slide, that at point P we are getting either maximum intensity or zero intensity depending upon this path difference. If the path difference is an integral multiple of lambda, then we get maximum intensity. If it is a fractional part, then we get zero intensity. So it all depends on what is the path difference between S1p and S2p. So to find out the condition, generalized condition for getting a maximum or minimum intensity at point P, then we have to find out what is this path difference, and we should express this path difference and in terms of this x value. So I start with a maximum intensity condition. So using the theory of interference, we get maximum intensity at this point P if the path difference is an integral multiple of lambda. So what is the path difference? S2p minus S1p is nothing but path difference, which is equals to n lambda. N can take 0, 1, 2 and so on values. If you consider this triangle S2PR, if you apply the Pythagoras theorem, then S2p square equal to S2R square plus PR square. I am taking this value now, S2p square minus S1p square. ಬಟ್ ನೀವು ಕನ್ಫ್ಯೂಸ್ ಆಗಿ ಮಾಡ್ಕೋಬೇಡ್ರಿ, ನಮಗೆ ಬೇಕಾಗಿರೋದು S2p minus S1p. ಬಟ್ ಯಾಕೆ ಇದನ್ನು ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂ ತಗೋತಾ ಇದ್ದೀರಾ ಅಂತಿಕೊಂಡು, ಬಟ್ ನಾವು ಸ್ಕ್ವೇರ್ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ಳೋದ್ರ ಮೂಲಕ ನಾವು S2p minus S1p ಅನ್ನ ಈಸಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. ನಿಮಗೆ ಸ್ಟೆಪ್ಸ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ದಂಗೆ ನಿಮ್ಗೆ ಮುಂದೆ ಗೊತ್ತಾಗ್ತದೆ ಇದು. ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ S2p square minus S1p square. ಯಾಕಂತಂದ್ರೆ a square minus b square ಈ ಫಾರ್ಮುಲಾನ ನೀವು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಿದರೆ ಯು ಗೆಟ್ a plus b a minus b. ನಮಗೆ ಬೇಕಾಗಿರೋದು a minus b ಅಂದ್ರೆ S2p minus S1p ಬೇಕಾಗಿರೋದು. ಬಟ್ S2p minus S1p ಬೇಕು ಅಂತಂದ್ರೆ ನಾವು ಈ ಫಾರ್ಮುಲಾನ ಅಪ್ಲೈ ಮಾಡಿದರೆ ನಮಗೆ S2p minus S1p ಸಿಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾನು S2p square minus S1p square ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀನಿ. Find out ಮಾಡಿದ್ಮೇಲೆ then I am going to find out the value for S2P minus S1P. Applying the Pythagoras theorem, S2P square equal to S2R square plus PR square. S2R square plus PR square. Then if you consider this triangle S1PQ, S1P square equal to S1Q square plus PQ square. S1Q square plus PQ square. Now writing the value for S2R square, S2R value is D, now it becomes D square. PR square, PR square is nothing but PC plus CR. So PC is X, CR is D by 2, X plus D by 2 whole square. S1Q square, S1Q is again equals to capital D square plus PQ square. PQ square is nothing but PC minus QC. PC minus QC ಅಂದರೆ X ದಲ್ಲಿ ನೀವು ಈ D by 2 ಮೈನಸ್ ಮಾಡಿಬಿಟ್ರೆ ನಿಮಗೆ PQ ಸಿಗುತ್ತೆ. So instead of PQ I am writing X minus D by 2 whole square. So now I am expanding X plus D by 2 whole square using the formula A plus B whole square. A plus B whole square equal to A square plus B square plus 2AB. Similarly, I am expanding this term as X minus D by 2 whole square equals to A square plus B square minus 2AB. So I am writing this expression S2P square minus S1P square value as I am writing this term D square plus A plus B whole square equal to A square plus B square plus 2AB. So X square plus D by 2 whole square plus 2AB means 2XD by 2, 2XD by 2 minus D square plus A minus B whole square equal to A square plus B square minus 2AB. A square is nothing but X square. I am writing D square as it is. Now I am expanding this term X square plus D by 2, D by 2 whole square minus 2AB minus 2XD by 2 minus 2XD by 2. So if I write this step, now I am going to simplify this step by cancelling some terms D square, X square and D by 2. First three terms get cancelled because of this minus sign. This D square, this D square, this is a plus D square, this is a minus D square, plus X square minus X square plus D by 2 whole square minus D by 2 whole square get cancel each other, but leaving plus 2x plus 2xd by 2 minus of minus plus 2xd by 2, so it will be equals to 4xd by 2. So S2P square minus S1P square, it is nothing but A square minus B square equal to A plus B, A minus B. So S2P plus S1P into bracket S2P minus S1P is nothing but S2P square minus S1P square. We want this term. This is nothing but path difference. So here 4xd upon 2 I am writing it as 2xd. I write it equation number 2. Now I am going to write the expression for this term S2P minus S1P equal to 2xd divided by this term comes to the numerator part S2P plus S1P. For typical interference, this S1P and S2P, they are almost equal. They are almost equal. You can take it as 2D. That is S2P plus S1P is equals to 2D because S2P and S1P they are almost equal to capital D. In such case, S2P plus S1P can be written as 2D. Now this expression S2P minus S1P equals to 2xd small d divided by 2D. This is a capital D. Now we can write the last step by simplifying it further by cancelling this two term Now we get S2P minus S1P equals to XD divided by capital D. So this is equation number 3. So this is nothing but a path difference in terms of X, D and capital D. This is a very important step in the examination. Up the derivation up to this step may be asked. So if they ask to derive the path difference, then you have to arrive at this equation XD upon capital D. Now if you have a interference on the screen, you will get a central bright region, then surrounded by alternate dark and bright region. So this peak value indicating bright region and this downward peak indicating dark region. So this is a central bright region, this is a first dark region, this is a first uh, bright intensity, this is a second dark region, and this is a second bright intensity bright region. In this way you are getting alternate dark and bright regions. I'm treating this bright region as 0. I'm counting all the subsequent bright band and dark band from this reference region, bright region. So that is why I'm not counting it. I treat it as a 0. So I want to find out nth bright region. Nth bright region means I can have a bright region, first bright region from this central bright region. So this is the first bright region. The distance of the first bright region is, we can take it as x value. So this is nothing but the distance of first bright region from the center of the screen. So if you take this distance, this is a distance of second bright region from the center of the screen. This is the distance of a second bright region from the center of the screen. So to find out the distance of each bright region from the center of the screen, then we need uh, a simple recap. Again we need this diagram, but you need not to write the diagram again and again since the slides are changing. So from the condition of bright region, the position of nth bright region from the center of the screen is, so path difference S2P minus S1P equal to n lambda. You know this path difference is always equals to an integral multiple of lambda, then you get maximum intensity. So for every bright region, so this condition should be fulfilled. According to the previous derivation, the path difference S2P minus S1P is equals to XD upon D, which is equal to n lambda. Then this x value is nothing but the distance of any bright region, first, second, third, fourth and so on. Andre center of the bright region ದಿಂದ ಫಸ್ಟ್ ಬ್ರೈಟ್ ರೀಜನ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ, ಸೆಕೆಂಡ್ ಬ್ರೈಟ್ ರೀಜನ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ, ಥರ್ಡ್ ಬ್ರೈಟ್ ರೀಜನ್ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ ಅಂತಿಕೊಂಡು ಆ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡೋಕೆ ಈ ಫಾರ್ಮುಲಾ ನಿಮಗೆ ಹೆಲ್ಪ್ ಆಗ್ತದೆ. ಸೊ ಎಕ್ಸ್ ಎನ್ ಈಸ್ nth ಬ್ರೈಟ್ ರೀಜನ್ ಅಂತ ಕರಿತೀನಿ. nth ಬಿಕಾಸ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ದಿಸ್ ಫಾರ್ಮುಲಾ ಇನ್ ಅ ಜನರಲೈಸ್ಡ್ ಫಾರ್ಮ್. ಇಫ್ ಐ ಟೇಕ್ n equal to 0, then I get a central bright region. If I take n equal to 1, I get the distance of the first bright region from the center of the screen. If you take n equal to 2, then I get the distance of second bright region from the center of the screen. In this way, by putting the value of n, I can get the distance of any bright region from the center of the screen in terms of lambda, d and small d. So this is a very important expression. So we can write the same expression for angle also. This is a distance, this is a x is a distance of any bright region from the center of the screen. It is the distance x of any bright region at point P from the center of the screen. For example, ಈಗ ನಿಮಗೆ ಮೊದಲೇ ಬ್ರೈಟ್ ರೀಜನ್ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಅದು ಸೆಂಟರ್ ಆಫ್ ದಿ ಸ್ಕ್ರೀನ್ ಇಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ, ಎಕ್ಸ್ ದೂರದಲ್ಲಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಹಾಗಾದ್ರೆ ಇದು ಈ ಮೊದಲೇ ಬ್ರೈಟ್ ರೀಜನ್ ಇದೆಯಲ್ಲ, ಎಷ್ಟು ಆಂಗಲ್ ನಲ್ಲಿ ಇದು ಕ್ರಿಯೇಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ಇದು ಥೀಟಾ. this is a theta is the angle at which the first bright region is formed. If you take second bright region point P ನಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. So you can find out at what angle this second bright region is formed. So in the same way, how we have calculated the distance of every bright region from the center of the screen, so we can find out the angle at which every bright region is formed from the center of the screen. So center of the screen ದಿಂದ ನೀವು ರೆಫರೆನ್ಸ್ ಲೈನ್ ಇಟ್ಕೊಂಡು ಸೊ ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಈ ಬ್ರೈಟ್ ರೀಜನ್ ಗಳು ಫಾರ್ಮ್ ಆಗಿದಾವೆ, ಮೊದಲೇ ಬ್ರೈಟ್ ರೀಜನ್ ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಿದೆ, ಎರಡನೇ ಬ್ರೈಟ್ ರೀಜನ್ ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂತಿಕೊಂಡು ನೀವು ಕಂಡುಹಿಡಿಯಕ್ಕೆ ನೀವು ಈ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಬಹುದು. So we know path difference is equal to n lambda. So here from this triangle S2 S1 n S2 S1n, this small triangle ಇಲ್ಲೊಂದು angle ಕಾಣುತ್ತೆ ನೋಡ್ರಿ, S2 S1n ಅಂತ ಇದೆಯಲ್ಲ, this angle is a theta. Then this value S2n value, by applying the trigonometry we can find out the value of S2n as d sin theta. D sin theta n because I can take this theta for any bright region. If you put n equal to 1, theta will be the angle of the first bright region. If you take n equal to 2, then theta 2 becomes the angle of second bright region. So ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಈ ಬ್ರೈಟ್ ರೀಜನ್ ಗಳು ಫಾರ್ಮ್ ಆಗಿದಾವೆ ಅಂತ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಈ ಫಾರ್ಮುಲಾ ನೀವು ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಸೊ ಡಿ ಸೈನ್ ಥೀಟಾ ಎನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ S2n. S2n ಅಂದ್ರೂ ಒಂದೇ, ಡಿ ಸೈನ್ ಥೀಟಾ ಎನ್ ಅಂದ್ರೂ ಒಂದೇ. ಅಂಡ್ ಸೈನ್ ಥೀಟಾ ಎನ್ ಅನ್ನ ನಾವು ಬರೀ ಥೀಟಾ ಎನ್ ಅಂತ ತಿಳ್ಕೊಂಡು ಬರಿಬಹುದು ಇಫ್ ದಿಸ್ ಥೀಟಾ ಆಂಗಲ್ ಈಸ್ ವೆರಿ ವೆರಿ ಸ್ಮಾಲ್. ಇನ್ ಸಚ್ ಕೇಸ್ d sin theta n can be written as d theta n equal to n lambda. Then theta n equal to n lambda upon d. So this is another important formula. ನೋಡಿ ಈ ಎರಡು ಫಾರ್ಮುಲಾಗಳನ್ನು ಕರೆಕ್ಟ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. xn equal to n lambda d upon d ಇದೆಯಲ್ಲ, this is the distance of any bright region from the center of the screen. Theta n equal to n lambda upon d ಇದೆಯಲ್ಲ, this is the any angle at which the bright regions are formed from the center of the screen. Similarly, we can calculate the same scenario for dark region. Suppose this is the central bright region. From the central bright region, so we can calculate the distance at which the first dark region is formed. The distance find out ಮಾಡಬಹುದು. We can find out this distance, the distance of second dark region from the center of the screen, and we can also find out at what angle the first dark region, second dark region, third dark region and so on are formed with respect to this horizontal line drawn from the center of the screen. ಈ center of the screen ದಿಂದ ಒಂದು horizontal line draw ಮಾಡಿದಿಲ್ಲ, ಈ ಲೈನ್ ದಿಂದ ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಫಸ್ಟ್ ಡಾರ್ಕ್ ರೀಜನ್, ಸೆಕೆಂಡ್ ಡಾರ್ಕ್ ರೀಜನ್, ಥರ್ಡ್ ಡಾರ್ಕ್ ರೀಜನ್ ಫಾರ್ಮ್ ಆಗ್ತವೆ ಅನ್ನೋದನ್ನ ನಾವು ಇಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಸೊ ಅಗೇನ್ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ದಿ ಸಿಂಪಲ್ ಕಂಡೀಷನ್ ಫಾರ್ ಡಾರ್ಕ್ ರೀಜನ್ ಯೂಸಿಂಗ್ ದಿ ಥಿಯರಿ ಆಫ್ ಇಂಟರ್ಫರೆನ್ಸ್. ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ಸ್ ಟು n plus half lambda. So if the path difference is equal to n plus half lambda, then you get a dark region. ಇಲ್ಲಿ ಡಾರ್ಕ್ ರೀಜನ್ ಫಾರ್ಮ್ ಆಗಿದಾವಲ್ಲ, ಲೋವರ್ ಪೀಕ್, ಇವೆಲ್ಲ ಡಾರ್ಕ್ ರೀಜನ್ ಯಾವಾಗ ಫಾರ್ಮ್ ಆಗ್ತಾವ ಅಂತಂದ್ರೆ ಈ ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಏನಿದೆಯಲ್ಲ, n ಪಾತ್ ಡಿಫರೆನ್ಸ್ ಈಕ್ವಲ್ ಟು n ಪ್ಲಸ್ ಹಾಫ್ ಲ್ಯಾಂಬ್ಡಾ ಅಂತ ಏನಿದೆಯಲ್ಲ, ಇದು ಫುಲ್ಫಿಲ್ ಆದಾಗ ಮಾತ್ರ ಈ ಡಾರ್ಕ್ ರೀಜನ್ ಗಳು ಫಾರ್ಮ್ ಆಗ್ತವೆ. ವಿ ನೋ ದಟ್ ಫ್ರಮ್ ದಿ ಯಂಗ್ಸ್ ಡಬಲ್ ಸ್ಲಿಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, path difference is equals to xt upon capital D, and we have to write this term as it is, n plus half lambda. Then finally we get xn. x ವ್ಯಾಲ್ಯೂ ಏನಿಲ್ಲ, ಅದನ್ನೇ ನಾನು x ಅಥವಾ xn ಅಂತ ಬರಿತೀನಿ. ಬರೀ x ಅಂತ ಬರೆದ್ರೆ ಅದು ಜನರಲೈಸ್ಡ್ ಫಾರ್ಮ್ ಆಗೋದಿಲ್ಲ. xn ಅಂತ ಬರೆದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಅ ಜನರಲೈಸ್ಡ್ ಫಾರ್ಮ್. xn equal to 2n plus 1 lambda d upon 2d. ಇಲ್ಲಿ ಏನಿದೆಲ್ಲ n plus half ಏನಿದೆಯಲ್ಲ ಅದನ್ನು ನಾನು 2n plus 1 upon 2 ಅಂತ ಬರಿತೀನಿ. ಅಂದ್ರೆ ಈಗ ನೋಡ್ರಿ, ಈಗ n plus half equal to 2n plus 1 upon 2 ಅಂತ ಆಗುತ್ತೆ. ಅದನ್ನ ಇಲ್ಲಿ ಬರ್ತಿದ್ದೀನಿ. So this is a important formula. Then this formula gives us a distance of any dark region from the center of the screen. If I put n equal to 0, then you get the first dark region from the center of the screen. If you put n equal to 1, you get the second dark region, position of the second dark region from the center of the screen, and so on. So we can find out at what angle these dark regions are formed from the horizontal line drawn from the center of the screen. As it is, we have to repeat the same formula here. Path difference equal to 2n plus 1 lambda d upon t. But here we have to write d sin theta n instead of xd upon d. xd upon d, this is also path difference, but this is a path difference expressed in terms of xd and capital D. Whereas d sin theta n is also path difference, but expressed in terms of small d and theta n. As I told in the previous slide, by taking this triangle S2 S1 n, if I take S2 S1 n as an angle theta, then if you write the value of S2 n as d sin theta n, so d sin theta n can be written as d theta n, where this sin theta n is equals to theta n if this angle theta is very small. Then theta n can be written as 2n plus 1 lambda upon 2d. This is another important formula. So ನಿಮ್ಗೆ ಗೊತ್ತಿರಲಿ, xn equal to 2n plus 1 lambda d upon t ಇದೆಲ್ಲ, this is a generalized form which gives us the distance of any dark region from the center of the screen. Whereas theta n equal to 2n plus 1 lambda d upon 2d gives us the angle at which any dark region is formed from the center of the screen. ಅಂದ್ರೆ ಇದು ಫಸ್ಟ್ ಫಾರ್ಮುಲಾ, 5ನೇ ಫಾರ್ಮುಲಾ ಏನಿದೆಯಲ್ಲ, ಇದು 5th ಇಕ್ವೇಶನ್ ಏನಿದೆಯಲ್ಲ, ಇದು ನಿಮಗೆ ಸೆಂಟರ್ ಆಫ್ ಸ್ಕ್ರೀನ್ ಇಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿ ಈ ಡಾರ್ಕ್ ರೀಜನ್ ಗಳು ಫಾರ್ಮ್ ಆಗ್ತವೆ ಅನ್ನೋದನ್ನ ನಿಮಗೆ ಮಾಹಿತಿ ಕೊಡ್ತದೆ. ಸೊ ಈ 5a ಇಕ್ವೇಶನ್ ಇದೆಯಲ್ಲ, ಇದು ಸೆಂಟರ್ ಆಫ್ ದಿ ಸ್ಕ್ರೀನ್ ಇಂದ ಯಾವ ಆಂಗಲ್ ನಲ್ಲಿ ಈ ಡಾರ್ಕ್ ರೀಜನ್ ಗಳು ಫಾರ್ಮ್ ಆಗ್ತವೆ ಅನ್ನೋದನ್ನ ನಿಮಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡುತ್ತೆ. Now we go to the derivation of the fringe width. Thus dark and bright bands of interference pattern are called fringes, and the distance between any two consecutive bright and dark fringe is called fringe width. ಅಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಎರಡು ಬ್ರೈಟ್ ರೀಜನ್ ಅಥವಾ ಯಾವ್ದಾದ್ರು ಎರಡು ಡಾರ್ಕ್ ರೀಜನ್ ನಡುವೆ ಇರುವಂತ ಒಂದು ಅಂತರವನ್ನ ನಾವು ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಅಂತ ಕರಿತೀವಿ. So if you take this diagram, this is the central bright region. ಸೊ ಈ ಸೆಂಟ್ರಲ್ ಬ್ರೈಟ್ ರೀಜನ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬ್ರೈಟ್ ರೀಜನ್ ಬರೋದು ಯಾವ್ದಪ್ಪ ಅಂದ್ರೆ ಫಸ್ಟ್ ಬ್ರೈಟ್ ರೀಜನ್. ಇವೆರಡು ಬ್ರೈಟ್ ರೀಜನ್ ನಡುವೆ ಇರುವ ಅಂತರನೇ ನಾವು ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಅಂತ ಕರಿತೀವಿ. ಬಟ್ ಈ ಸೆಂಟ್ರಲ್ ಬ್ರೈಟ್ ರೀಜನ್ ಮತ್ತೆ ಥರ್ಡ್ ಬ್ರೈಟ್ ರೀಜನ್ ಈ ನಡುವೆ ಇರುವಂತ ಅಂತರವಲ್ಲ, ಇದನ್ನ ನಾವು ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಅಂತ ಕರೀದಿಲ್ಲ. ಸೊ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಅಂತಂದ್ರೆ ಏನು? ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಎನಿ ಟೂ ಕಾನ್ಸಿಕ್ಯೂಟಿವ್ ಬ್ರೈಟ್ ಫ್ರಿಂಜ್ ಆರ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್. ಸಪೋಸ್ ಇಫ್ ಐ ಟೇಕ್ ಫಸ್ಟ್ ಡಾರ್ಕ್, ದೆನ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ first and second dark region is called fringe width. ಇದಕ್ಕೆ ನಾವು ಏನು ಕರಿತೀವಿ? ಕಾನ್ಸಿಕ್ಯೂಟಿವ್ ಬ್ರೈಟ್ ಆರ್ ಡಾರ್ಕ್ ಫ್ರಿಂಜ್ ಅಂತ ಕರಿತೀವಿ. ಸಪೋಸ್ ಇಫ್ ಐ ಟೇಕ್ ದಿಸ್ ಫಸ್ಟ್ ಡಾರ್ಕ್ ಆಸ್ ಎ nth dark fringe, then n plus 1th will be second dark region. Suppose if I take second bright region as a nth bright region, then the next bright region will be n plus 1th, that is third bright fringe. And the distance between second and third bright fringe is called fringe width. So let us take this formula. Xn equal to n lambda d upon small d is a generalized form of the distance of any bright fringe from the center of the screen. And n plus 1th, wherever n is there, you have to replace it by n plus 1. ಅವಾಗ ಏನಾಗುತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದು n plus 1th bright fringe ಆಗುತ್ತೆ. Suppose if I take n equal to 3 ಅಂತ ತಗೊಂಡ್ರೆ fourth bright fringe ಏನಿದೆಯಲ್ಲ ಅದು n plus 1 ಆಗುತ್ತೆ. So in place of n you have to write simply n plus 1, nothing else. ಇವೆರಡು ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ the difference between n and n plus 1th bright fringe. That this distance is called as fringe width. You have to subtract the distance of nth bright fringe from n plus 1th bright fringe. Then you get a fringe width. So n plus 1th bright fringe is n plus 1 lambda d upon d minus nth bright fringe is n lambda d upon d. If you subtract and simplify, you get a fringe width lambda d upon capital D. So this is a called fringe width, and we have arrived at this expression by taking any two bright fringe. Similarly, we can arrive at the fringe width by taking any two consecutive dark regions. This is a generalized form of nth dark region, dark fringe. Xn equal to 2n plus 1 lambda d upon 2d. This is a generalized form. This is the distance of any dark fringe from the center of the screen. Then you can write the distance of n plus 1th. So now I can take the distance of n plus 1th dark fringe from the center of the screen. You have to just write n plus 1 in place of n. So xn, you have to write it as xn plus 1 and 2 into n plus 1. In place of n, you have to write n plus 1. Then plus 1 as it is lambda d upon small d. Then if you take the difference between these two distances, xn plus 1 and xn, then you get a fringe width. Xn plus 1 minus xn. This is the distance of n plus 1th dark fringe. You have to write it as it is minus the distance of nth dark fringe, 2n plus 1 lambda d upon d. If you simplify, then you get fringe width equal to lambda d upon small d. Then you get fringe width beta equal to lambda d upon capital D. The fringe width beta, we got it for any two bright or dark fringes. The fringe width beta, we got it for any two consecutive bright or dark fringes. The interference fringes are equally spaced. If you calculate the fringe width for dark region, you are getting lambda d upon capital D. If you calculate the fringe width for any two consecutive bright fringe, then you get the same value lambda d upon capital D. From this expression, we conclude that interference fringes are equally spaced.